the agenda for the talk looks like this. I'm gonna start to get to know you a little bit, and then you are forced to know a little bit about me. And then we're gonna have an introduction to Kotlin. What is Kotlin? Why was it created? And then we're gonna go, we're gonna go into the features of Kotlin, have a little walkthrough of the language. But then after that, we're going to look at some libraries and frameworks. And then in the end, we're going to look at some pros and cons. So the goal of this talk is to introduce Kotlin. And but I'll try to also cover some, beyond the basic, some of the beyond the basic stuff. So if you're already familiar with Kotlin, I hope that you'll at least learn something from this talk. Okay, so let's start with the survey. Who's already working with Kotlin? Okay, yeah, good. And who would say that they're already somewhat familiar with Kotlin? Okay, a little bit. And who would characterize themselves as Java developers? Okay, most of you. And for those of you who are Java developers, are you backend developers? Okay, quite a lot. And Android. And are you familiar with Java 8, or especially Lambdas? Okay, so most of you are. Okay, so that's good. Oh, who are familiar with the Scala and Groovy or blah, 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 blah. Okay. Good. No, because I have quite a lot of slides. I'm not sure how long this presentation will be, but I have just 143 slides. So good luck staying here until the end. Yeah. Okay. So, I am a backend developer at Parkster. No, I should probably say that this is actually the first time ever in a talk that I have a slide about myself. And I will tell you why in just a second. So I'm a backend developer, and I work at Parkster. No, it's not here. I work at Parkster, which is this digital parking service that you can use. You can use our app, use end user. You probably use that to start your parking, stop your parking, and extend your parking. And if you don't use it, you should. It's available here in Malmö and Lund and quite a lot of places in Sweden by now. And Parkster is also hiring, by the way. Good to know, right? But I'm primarily developing Java and other JVM-based languages. And I found a couple of open source libraries that you may have heard about. But the reason why I have this slide is because of Kotlin. And I'm currently just looking into Kotlin. I've not used Kotlin in production. I'm just this guy who wanted to learn the language. And I thought that, wow, if I emailed Mikael and say that I'm going to give a talk, I have to at least read a book. So this is really like, conference-driven learning or development, or So we'll see how that goes. So you have to help me out. We'll see. So currently we are evaluating Kotlin for server-side use at Parkster. This talk actually came about as an internal conference activity that we had. We've been talking about using it, but we kind of said that it's okay, but we haven't started using it yet. On the server side, but in the client we're already using it in production. Oh, did I say that Parkster is hiring? If not, we are. So come and talk to me or visit our webpage if you want to know more. What is Kotlin? So Kotlin is statically typed. It's object-oriented with the functional constructs, which essentially means that you can use both object-oriented object-oriented programming styles and functional programming styles and kind of mix them. So Kotlin has support for first-class, first-class support for higher-order functions and function types and lambdas and all sorts of things. So if you aren't into functional programming, Kotlin could be a good first step to get into that. It's also pragmatic, and I think that this is really one of the strengths of Kotlin. It's not a research language, and it's not trying to advance the state of the art in compilers. Instead, it just tries to bring in ideas from other languages, proven ideas from other languages, and kind of mix them into Kotlin. And I actually think that is one of Kotlin's strengths. It's open source, it's Apache 2 license, both the compiler and the IntelliJ plugin. It's designed to be interoperable with Java and Android, so this was really a goal of Kotlin from the start. But it also compiles to JavaScript and to native as well. I've never tried either JavaScript or native, so I don't know how well it works, but yeah, it's supposed to work. And Kotlin is also concise and expressive, especially if you compare to vanilla Java. And this means that it's easy for both a human being and a compiler to understand the language. And also they try to strike a balance between few characters in the code and the readability, because they really emphasize readability of the code. And this is of course subjective, but personally, I hope, yeah, attest to this, I hope. It's easy to learn, especially if you know like Java and some other JVM languages like Scala and Groovy. Then you probably know like 80% of Kotlin, or maybe not 80%, 70%, 72%, something like that. I was remembering this quote. Yeah. When it comes, oh, I should actually say this because I have a pretty good. Do you have a mouse? Yeah. So regarding pragmatic, now I'm going back. But yeah, there's this quote I found somewhere on the internet, which must be true. So it says that Kotlin achieves 80% of Scala's power with 20% of the complexity. And of course, I don't know if these numbers are correct, but kind of something like that. Yeah. Okay, so now we jump back and say that it's tool-friendly, and that's true because it's developed by JetBrains, and Kotlin, the language and compiler, is developed alongside the IntelliJ plugin for Kotlin. So they really emphasize on the tool friendliness. Yeah, and it's also safe. Well, it's statically typed, first of all, but it also has some really interesting ideas about null safety that we'll look into in a second. I've already spent 8 minutes. I have to, I don't know, slide 6 of 143. Okay. Okay, but this is interesting. I don't know if you can see this, but as I said, I'm not creating this language myself, so I haven't made all of this stuff up. I've read this somewhere on the internet, most of the things, or in books somewhere. So, well, I've borrowed things from links that I have here on, well, essentially each slide. So if you want to look up from where I've actually got this information, you can just follow the link that I have on each slide. So I don't want to take credit for what I actually say. Okay, so why was Kotlin created? It was created back in August of 2011, and JetBrains, back then the JetBrains team were writing everything in Java, but they wanted something that was well, more expressive and that allows them to create code faster. So why not create your own language? This sounds reasonable. And but of course there were other reasons, perhaps maybe to drive sales. But they're probably their commercial tools, like the, what's it called? The Ultimate Edition of IntelliJ. So maybe in the future there will be some enterprise support for certain Kotlin frameworks or libraries, perhaps. But also to drive the company's business by keeping trust. What do I mean by that? Oh yeah, they want to drive the company here. Maybe I should read it. JetBrains is trusted by a lot of professional developers. They want to drive the company's business as well as attract more people to their approach of development tools and increasing community awareness of JetBrains and maintaining trust. Yeah. Okay, so yeah, this looks good. But yeah, there are many companies that are using Kotlin already. I mean, we have yeah, Netflix, Uber, Trello, and Pinterest. They are using Kotlin along with other languages. And yeah, you can see that Kotlin has kind of risen in popularity. Just yeah, this year and last year it has really grown quite a lot. And oh, this is quite very interesting. At Google I/O, Google said that they will support Kotlin as a native language for the Android platform. That is quite big. Yeah. Yeah. Okay. Now we're going to go into the next part. And oh, just raise your hand if you have questions or comments, or if you think that I've like missed something, or I don't know. Just want to, say something. But we're going to start off looking at functions. Yeah. So I hope that you can see this. This is a function, and yeah, essentially you have the keyword fun, and then the name of the function. You have a variable name, and then you have colon, and then the type. So it kind of looks like what you see in Scala. And then the return type, for those who are used to Java, it is not defined before the method name, it's defined after the method name. And in this case, as you can probably guess, it will return the sum of A and B. So you can write it like this, but Kotlin has type inference, so you don't actually have to specify everything, which is kind of nice. So this function can actually be written like this, with a so-called expression body. And if you do that, you don't have to specify the return type, because that's preferred by the compiler. And you don't have to specify this block. And if you're using expressions in Kotlin, like the one we see here, you don't need to include return either. That is implicit. Yeah, so that's a function. And now we move on to variables. You can see why I have so many slides. Oh yeah, this is quite nice. At least if you compare it to some other languages. So in Kotlin, you can separate variable declaration by val and var. So if you have a val, then the reference is immutable. And I will show you an example just in a second. But if you declare the variable with the var, then you can then it's mutable, so you can change the reference. And this is really important. That you can see here that I've tried to highlight reference here. It's the reference that's immutable. It's not the actual data that's immutable. I thought that the data was immutable, so I was kind of yeah, this was a little bit of a letdown, but you can imagine that this is probably to keep interoperability with Java, I suppose. So with that in mind, I think that it's still very good to have these separated. Oh, no, I didn't have more examples. Well, maybe I do. Yeah, okay. So yeah, here's another really important thing in Kotlin, is that you can have these, what are they called? I don't remember that now. What are these called? No, it's not optional. Nullable types, I think. It's not the same thing as optional. But for all types, you can specify this question mark at the end, which means that it becomes a nullable type. So here we have an immutable reference email that is string, and this string is now nullable. And this is, yeah, so there you can see that you can assign it to null if you like. But if you only declare the email to be string, you cannot set it to null. Then you will have a compile time error. And this is really good. I mean, null is this billion-dollar mistake. It's not something that we want to deal with, but we have to deal with it in most languages. And so, yeah, this can really help us. The compiler really helps us here in most cases. Sorry? Yeah. No, there aren't. Okay, good. Okay, so, yeah, okay. So first of all, there are no primitive types. That's true. But they are. But if you use like there is something called int. So yeah, you can have the nullable type int. Yeah. Okay. Yeah, exactly. Yeah. So for those of you watching, what we have concluded here is that val is like final in Java, essentially. Yeah, thanks. So yeah, and I should also say this. I actually missed that. I'm also here to learn. So thanks. Yeah, here's an example. So yeah, now you have a mutable reference a. That's a string. So now if you try to declare a as null, you will get a compilation error. But if you declare it with the string question mark, then it's okay, be null. And of course, you want to not have these question marks in most places. You want to just have the non-nullable types. And this is also really cool, because now the compiler can help you with stuff like this. So now if you cannot do this b.length, because you have to check if this is null first. Otherwise, you will also get an error. No. Oh. Yeah, and you can. I will show that, I think, in just a few slides. You can get around this if you really like. Yeah, and this is also, I mean, if you do now with a, since you don't have a question mark, you can be sure that this will not cause a null pointer exception. Yeah. Yeah, you don't explicitly define the type. Yeah. 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 What is this? Oh, no, I remember. Okay. This is something that you typically see in Java. You do some null checks and blah, blah, blah. Then you want to get the length of the thing that is not null, in this case. But Kotlin, I think this is taken from Groovy. I'm not sure if this is available in other languages, but you can use this question mark here instead. Just remove the if statement. So this is the same thing. So if you use b question mark and then length, if now b is null, then null will be returned from this statement. And yeah, you can also use this for chaining. Of course, you don't want to chain things too much, but this can be really useful. And then there's something called the Elvis operator. and that is also from Groovy. But this is also something that you see all over the place in Java. If something is not null, then do something with it. Otherwise, return something else. And then you can use this this little thing here. This kind of looks like Elvis, right? If you kind of flip it around a little bit. So this is the same thing, just a bit more concise. So just, yeah, if B is not null, return the length. If null is returned from here, then we return -1 instead. Oh, and this is like, yeah, if you like null point conceptions, or if you run into cases where the compiler cannot, you know more than the compiler essentially. Maybe you're interacting with Java or something, and you know that this is not null. So you want to like force the compiler to actually invoke this without you getting a compile time error. You can actually do that with this double exclamation mark. It's called exclamation mark. Is it? Yeah, good. Yeah. Oh, yeah, and here's another kind of nice feature. It's safe casts. So in this case, or well, in many cases in Java, you want to like check if something is instance of another type, and if it is, then we cast it. So here you can actually, you don't have to do that. Here you can like see if a is an int, then it will return this as an integer, but if not, null will be returned, which is quite good. Yeah. So now we're gonna look at packages, and yeah, you should probably. Okay, I should probably say this. I will go for about. I think the agenda said something like 45 minutes before. Well, actually, we should wait until the pizzas, and then I will stop, and then we'll have pizzas. Maybe that's better. Then I just have a time, and we just sit there without. Okay, let's do that. Okay, so packages. This is really cool, I think, because packages in Kotlin can have functions, not only classes, like you have in Java. So you can have, well, functions, and you can also have properties in a package. But it's especially nice to have functions, because many times in Java you create these like utility classes. Yeah, you have them all over the place. But what you probably want is just maybe a function in your package. And it also encourages you to do, well, yeah, perhaps even better design. Languages such as Closure, you define, it's automatic to define functions in your package or namespace, and only use of functions. It's better, you can perhaps more easily compose functions this way, and you don't have to actually couple your functions to a specific class, which is really nice. There's a book. Oh, yeah. No. No. No, they're not static. Yeah, they're a separate class, but they're not static. Okay, maybe they're static. But I don't. Yeah. Okay, maybe they are. I don't know. If you say so, they probably are. Well, I thought they were not. Yeah, that's so strange. Okay. Okay. Yeah. Yeah, you're probably right. Okay, thanks again. Okay, so yeah, here's just an example of how you can import things. Oh, and yeah, this is pretty nice, I think. So if you have, this is, I'm sure you've all seen this in Java when you import classes that are called the same thing from different namespaces or packages, then you will have a clash, and you have to like use the fully qualified name of the class. But in Kotlin, you can create like this alias. So here you can see that we have 2 bars that we import. So then you can like specify one of the bars here to be called B bar, so you don't have to use the fully qualified name. Yeah. So then we're moving on to strings. Or actually, yeah, what I was about to say here before was that I was reading quite a good book that I can recommend. That is called Functional Reactive Domain Modeling. It's kind of all the buzzwords in one title, but it's actually a very good book. It's written in Scala, but I think it also highlights some of the goodness that you can have if you define the functions in packages instead of classes. So that kind of confused me a little bit, that book, because I was reading that at the same time I was reading Kotlin an action book. You have to get Scholars in there. Okay, so strings. Well, first of all, we in Kotlin have these string templates. That if you're familiar with Groovy, this is the same thing essentially. So you can actually, you can reference variables like if you use this $sign from inside strings, which can be quite handy. And yeah, you can also, if you have an entire block like this, you can wrap them in these dollar. Oh no, what is this called? Mouse. Yeah. curly brackets. Yes, thanks. Curly braces, exactly. Yeah, so this is kind of nice. Another kind of nice thing is that you can have multiline strings. And here is an example of that. There are some utility functions that you can use here as well. Yeah. Maybe. I've just, you know. Yeah, but that could be. I've seen other examples where you have this pipe character here as well, and you can kind of remove that. You call a function afterwards, and because you can define any character here. The pipe, I think the pipe is default, and you can like, at least I think so. There is a function that you can use that defines the character that you're using inside the multiline string. But I think the default perhaps is pipe. Okay. So classes. This is something that can be quite verbose in Java, and they've managed to make it more concise in Kotlin without losing readability, I would argue. So here's an example of a class. It's called item manager, and here you declare the constructor of the class. So here you can see that we take a value, category ID as a string, and then we take another value as category ID as a string. And you can see here that we also have a var email. So these are called properties, and what will happen here is that Kotlin will automatically generate, since this is a val, it will automatically generate a getter only. But if it's a var, it will generate both a getter and setter automatically. So you don't have to do that explicitly. And when you instantiate a class in Kotlin, you don't need to use the new keyword. The new keyword doesn't exist in Kotlin. So you only call a class like this. You pass in the arguments. But what's also cool is that you can have named arguments. So here you see that we have, and then you can pass in the arguments in any order that you like. This is quite nice for readability sometimes. And I find that it also, you don't, sometimes you create builders in Java for only these kind of scenarios. when you have a lot of things that you want to take into the constructor. We have a lot of arguments to the constructor. But you don't have to create builders, I find, as often in Kotlin as in Java because of this. And you can also mix, so you can have like partially named arguments, where some arguments are unnamed and some arguments are named. And yeah, here's an example of a secondary constructor. So if you have a second constructor, you use the constructor keyword, and this constructor takes the category ID and the DB connection, and then also email as an additional argument. And this is also nice because here the compiler can infer that this must be a val, because it's a val here. We're calling this constructor from we're calling the primary constructor from the secondary constructor. Yeah, then we can instantiate it like this. Yeah, okay, so inheritance. So by default, you just specify class, like we did here. The class will be the equivalent of the final in Java. So if we want to be able to extend from a class, we need to declare it explicitly as open. This is what we're doing here. Here we have an item, we have explicitly declared it as open. And likewise, the functions that we want to be able to override will be declared open. And yeah, here we see a class that now extends this item class. And you do that with the colon, and then you specify the type, and you supply the arguments to the constructor in the same line. Yeah. And when you override the function, you specify the override keyword explicitly. So it's kind of the other way around from Java. Oh yeah, good, good. I was supposed to say that, but I would probably have forgotten it if you hadn't pointed it out. Yeah, here's another really cool thing. Because you can have default values for parameters. So here you see yeah, the name property here is a type string, and if you don't pass, now you can call item with only the ID. This is optional. So if you don't specify this parameter, we'll get the value unknown name, which is also nice. No, not from two classes, only from interfaces. It's the same as with Java. Yeah, which is good, I think. This I know. Yes, yeah. So the question was if I think that it's good that it's final by default, and yeah, I think so. But it can mess up some frameworks. That kind of depends on, for example, frameworks that create mocks, I suppose, or frameworks like Spring and stuff like that. But there are workarounds for Spring. But yeah, it can be yeah, it can be a little tricky with interoperability. But I think it's a good. I mean, you don't want to use inheritance most of the times. It's yeah, so you shouldn't do it. So this kind of this forces you to be explicit about it. So I think it's good personally. Yeah, another really good thing about Kotlin is this concept of data classes. So this is, as you can see, this is a class, but now we're also using the data keyword. And this is real nice because when we do this, Kotlin will automatically not only generate the getters and setters automatically, but it will also insert equals, hash code, and toString, and some other functions that you can use for destructuring. And there's, yeah, we'll actually see examples of this. Yeah. So here is another example of a function that you get for free with this data class. And this is essentially what this is like in Java. You create these DTOs all over the place. they can be quite big. I mean, and you always have to remember, if you're not using some tools like Lombok or something, you always have to remember, I need to regenerate my toString and equals and hash code every time I add some things here. And it, this piece of code would like be, I don't know, 50 lines of Java code. Where 49 of these lines are just unnecessary, because this is all you need. And yeah, so I think that this is really nice. No, it's like the equivalence of a Java object, like what's it called, a POJO. Yeah, a Java bean or a Java POJO. Yeah, but you also have another useful function that you get with data classes called copy. So if all your arguments are vals, which means that they're immutable, at least the reference. Then there is this utility function that you can use, copy, if you want to create like a copy of an instance. In this case, we create a user with name Jack and h1, and we want to increase the h. Then we can just do jack.copy with h equal 2, and you will get Jack back with this property changed to 2, which is nice. And then we have destructuring, which is just you kind of swear at Java every time you can't use destructuring. So this might not be the best examples, but we'll see more examples as we move on. Here we have, we've created a user, and now what we can do is to destructure Jane and extract we extract the property values out of Jane and name them name and age. And then we can use them here in the code. As you can see here, we do a print line with name and then age, like that. And this essentially exists in all other languages except Java, I suppose. So now we're going to look a little bit closer at properties in Kotlin. And you've seen examples of properties already. But this is the full syntax for declaring a property. And this is according to the reference documentation, so this should be correct. So you have the name of the property, and then the property type, which is optional, it can be inferred. And then you can have an initial value, and then optionally you can override the default getter and setter that is generated. So we've seen examples of this already, but here we'll see them one more time. So in this case, we have inferred, or the compiler have inferred, that this is of type int, and it will just get the value and set the value when the property is called. But to override a getter, you do like this. You specify the get method here, and then you can implement your own code for the getter. And in this case, this is actually a little bit interesting, because in this case, I don't know if it's obvious, but here we add this empty property, and this actually doesn't hold any state by itself. It only references other properties inside this class. So Kotlin figures this out and doesn't actually generate a field for this property under the hood. This is kind of nice. And as of Kotlin 1.1, you can actually write this as one line as well. Setter, you also override this kind of as you would expect. You create a setter with a value, and then you can create your own custom logic in the setter. And by default, maybe I haven't said that, but by default everything is public in Kotlin. But you can reduce the visibility. For example, you can use the private keyword to reduce the visibility of this setter, like this. And with some well, frameworks, etc., you might want to use setter injection. And then you can use annotations on setter like this. Another useful thing is this late init, because if you have scenarios like this, which is quite common when you create unit tests in Java, and as you said before, you have to initialize the variable in the constructor, but sometimes that is not feasible, or you don't want to do that. In this case, we want to create this subject here in our before method, or yeah, in our setup method. And we can do that if we use the late init keyword. Yeah, and this only works for var. It wouldn't make sense for val. Yeah. And yeah, okay. So this is just to show you that you can also override properties. But then again, you have to use open for both the class and for the value, and then you override it with the override keyword. Yeah. So now we're going to move on to something called object expressions. So in Java, it's quite typical that we create this anonymous inner classes all over the place. And in order to be interrupt with the Java, Kotlin has kind of created this object abstraction that can solve more use cases. But this is one of the use cases where you can use this object keyword, and that is to create a so-called object expression. So this is essentially, I don't know, maybe this is Swing or something, but this takes an abstract class as an argument. You can create an anonymous inner class or an anonymous implementation of that class using object mouse adapter, and then you override the methods. So that's one usage of the object keyword, and this is called object expression. Another use case is so-called object declaration. And this is essentially, so instead of a class, you define this constructor as an object. And what this does is that it creates a class and it creates an instance at the same time. So this is effectively a singleton. So many times in Java, at least in certain frameworks, you have to implement like singletons yourself, and either use synchronized or some more elaborate way of doing it. But this is quite easy. Yeah. No, me neither. Oh, it essentially means that you extend from that type and you call it constructor. At the same time. Yeah, I had it many slides ago. There are sort of so much animations. I don't want to go back, but this is yeah. And yeah, if you use object, then you essentially you can just call the functions, and they look like static methods from Java, but they are not static, right? Yeah, they are like singletons, and they're not static. Right. So another use of this object keyword is when we come to companion objects, because well, Kotlin doesn't have static. Static is not a keyword in Kotlin. So instead, Kotlin encourages you to create package-level functions and so on. But package-level functions cannot access private state inside a class. And sometimes you might want to do that. In Java, it's quite common that you have these factories to create instances or something. This is a way to get rid of these factories and replace that code inside a companion object instead. So what this actually does is that or now you can actually, the functions that are created inside this companion object can be called directly like this. So it looks like a static invocation call in Java, but it's not static. You can get a hold of the companion object doing myClass.companion. And now you can access private state from my class if you want to do that. Yeah, companion objects can also be named. So here, this is kind of I'm not sure if this is the correct term, but this is kind of an anonymous companion object, but you can give it a name explicitly. So you can call it factory if you like, and then the companion object will be called factory if you try to instantiate it like that. And when you call it from Kotlin, it usually doesn't matter. If you call it from Java, it might matter. Yeah, it's also important here, even though that this looks like static function calls, they're not static, but you can turn, for example, properties here into real static fields if you like, by using various annotations like JVM static. Yes, and then this is probably something that in Java, I mean, one of the first things you do is to bring in something like Guava or Apache Commons or something, and they include these small utility functions. Just check if something is null or else throw an exception. So this is just things that are built into Kotlin. We have check not null and require, and also require not null. And the difference is that check not null will throw an illegal state exception if that expression is null, and the require will throw an illegal argument exception. But it's just something that this is something that, yeah, at least in my experience, you use things like this all over the place in Java, for good or bad. But this is just built into Kotlin, which can be nice to know. Yes. Now we're going to talk a little bit about the type hierarchy in Kotlin. So here's a picture that I've stolen from this link. And here you can see some types in Kotlin. And what this picture shows here is that every type inherits from a type called any. Whereas in Java, everything extends from objects. Here it is any. And then we have another type called nothing that extends from all other types in Kotlin. And yeah, and then we have like this all the nullable types as well. Yeah, good question. But no, that's not multiple inheritance. I don't know. But this is, yeah. Let's move on. Nothing is actually, we'll get into this a little bit, yeah, just in like a slide or two. Yeah, it's magical, I think. Yeah, it's magical. Maybe I should just use that whenever I don't know anything. Just say it's magic. Right. So this essentially I just said, I think. Yeah, I think so. But the reason why the Kotlin classes doesn't extend object like we do in Java is because object is quite polluted, right? It has this. What are the functions? They have like what's it called? Invoke and wait and finalize and all of these kind of things that you should never use essentially. So this is the reason why Kotlin have any instead. So if you declare a class like this, it will implicitly inherit from any. But this is only true in compile time. At runtime, any will become object, which can be interesting to know. And now we have something called unit. which is another type. So Kotlin doesn't have the equivalent of the void that we have in Java. Instead, Kotlin has this unit. And unit means that nothing of interest is returned, essentially. You can think of unit that nothing of interest is returned. And there are a couple of reasons for why you want to have unit and not void. One reason is this one, because you cannot use this currently in Java. You cannot use void with generics, but you can do that with unit. Yeah, but it's not. Yeah, you can use void with the capital letter V, but it's not the same. Then you still have to do like return null and stuff like that. So it's not the same. Yeah. So here you can see we have some executor, blah blah blah. Then you pass in unit here, which would not be possible at least with the small void. What's it called? Inverse of capital V. But I think another good use case for unit, I think, is that, for example, in Java, if you use like mocking libraries like Mockito, you have this special syntax when you're mocking void functions. So all our functions, you have a certain way of doing it, but then, oh no, it's void. You have to remember that you do things kind of backwards. So now you can actually, you don't have to create, or you can use this to like make your APIs more consistent. And yeah, here's an example where unit is inferred by the compiler. So here we don't return anything of interest. We're just logging something, but the return type will then be unit. No. If log were to return int, then the type here would be inferred to int. Yeah, sure. Yeah. Yeah, exactly. So nothing is essentially this type that you can use to represent a value that cannot exist. But this is different from unit. So unit is more like this is nothing of interest. This is says no, this is not possible. And it's called an uninhabited type. And this is essentially, if you have a function, yeah, like this one, that throws an exception, it's not possible to return from this function. You will have an exception. So the type here will be nothing. So if we dig deeper into this example, or yeah, with nothing. So here, what happens in this case? So here we have probably Android, I guess, name intent here. And yeah, you invoke some method here to extract a string. You can see that we're expecting a string as a type. But if this string is null, then we use this Elvis operator and we call fail. So now what happens? If fail up here returns nothing, then we don't need to check for any nullability types here. We don't need to check null because we know that this fail function here only throws an exception. So we don't have to check for null. But if it returns unit, then we will actually get a compile error because it will not be able to, if this is null and it calls fail that returns unit, it will not be possible to assign unit to a string. So you can so yeah, if you want to be like explicit to say that this function should never return anything, you can explicitly declare the function as to return a nothing type. Yeah. Yeah. The only examples that I've seen with nothing are with exceptions, so I'm actually not sure if there are anything else. Maybe you know. No. And now it's time to look at if. And what's cool with if in Kotlin is that it's an expression, and it's not a statement. And that essentially means that if actually returns something. In Java, it doesn't return anything, which means that you can write functions with these expression bodies in just a one-liner. So yeah, other than that, ifs look like you would expect, I suppose. You can also use them like a statement. Like this is what you will typically see in Java, I suppose. But the key thing here is that you don't have to use it as a statement. And this is really good. So that's the if. Not too much to say about that. But then we have something that's quite nice, which is this when expression. And from what I understand, this is kind of something in between the switch statement that we have in Java and pattern matching that we have in Scala, for example. Covers, I don't think I have an example of that, but okay, so let's just first look at this example. This is essentially like a switch in Java, so you just pass in some parameter here to when, and then you check that, well, if the view here is visible, then this is probably Android, I suppose, then we return a toast that says visible. If it's invisible, we return a toast with invisible, and if none of these two match, we'll just return this instead. So there's a difference with the switch statement. In Java, remember we have to put the break all over the place here. Here it just stops, and the first expression here is matched, which is good. Yeah, here's another kind of nice feature. Pass in the entire view here. You can check the same thing as instance of, essentially. So here you check if the text view is instance of. And if it is instance of text view, the compiler understands that. You don't need to do an additional cast to the text view that you would have to do in Java, which is also kind of nice. You can also use when without arguments. So then you can use other properties declared outside of the when expression inside the pattern matching part here. So in this case, we check that if x is in this range, 1 to 10, then we return something. Else, if this is true, we return this value here, and blah, blah, blah. It continues. Now, the reason why I said that it's not full-blown pattern matching, now I'm not exactly sure about the definitions here, to be honest, but at least the pattern matching in Scala, for example, is more powerful. In Scala, you can do things like, if we go back to, no, we can stay here. If we were to pass in a list here to when, we could actually pattern match on values inside the list. We can check that, if the first index of the list is 1, and the second is any value, and the third value is 3, then we should match. We can't do that in Kotlin. So it's not as powerful as Scala, but it's at least way better than the switch statement in Java. And another nice thing that I think they've stolen from Scala are the sealed classes. And this is very handy actually, because here we have a class again, and now we declare it sealed. And we have a data class that extends from this sealed class. And we have two data classes that extend from this class, and then another an object declaration that also extends from this expression. And now what's good about this is the sealed classes, and it's what's it called? If you declare something sealed, you restrict the types. So you cannot have any other type than what you have declared here in this scope. And the compiler knows that. So if you have sealed classes and you use these in when expressions, you don't need to specify an else clause here. But the compiler knows that, okay, we have covered all the cases. We've covered const, we've covered sum, we've covered not a number. And if we forget, for example, not a number, we will get a compile time error, which is good, because this is, in Java, you can forget to add something in a switch statement, and you don't see it. You don't have any tests that will catch it. So that's kind of nice. Okay, moving on. Collections. This is also kind of nice with Kotlin. You explicitly tell Kotlin if you want a read-only collection. In this case, if you list off and then you pass in some arguments here, you will get a read-only list, which is different from immutable. It's, it's still, yeah, like with the val, like it's final, but you can still modify the reference. So you can still modify. Maybe no, you actually do that. No, you can't do that. That's good. Good stuff. So ignore what I just said. But then you have also, yeah. So if you want to be able to modify lists, you explicitly declared it as mutable list off. But there is actually a third case which Kotlin does not cover, which is kind of what I was mumbling about before. Is that maybe you want the list to be immutable, not read-only. Maybe you want to have a list, but you want to be able to, well, you want to be able to add to this list. So this is, yeah. No, yeah, okay, so I shouldn't say this. You want to be able to add something. Let's see how I... you want to add something that appends this something to... or say, okay, so let me put it some other words. If, let's say that this was immutable, you got a list of, and it's an items here now is immutable, not only read-only. This means that you will have these add functions declared here in items, which you don't have here in this. You cannot do add in this read-only list. But if it was immutable, you could do add. What will happen is that you will get a new list back, essentially, with the value added. So it's not the same value. This is why I was stuck on this thing. So it's not this, but it's another list with these values smartly copied. This is sometimes referred to as persistent collections. And yeah, there are various libraries in Java that implement it. Closure have persistent collections by default. And it's really nice once you get to work with that. It avoids a whole lot of problems. But still, I think this is really good to differentiate between read-only and mutable. The only thing I miss is persistent collections. Oh yeah, so here's how you declare a map. And we'll get into it. This is not something special. You can see here that this looks kind of special. Like you do 1, 2, x. This is the key and this is the value. What actually happens here is that we create something called a pair that we pass into map. And we will actually see how we can create stuff like this ourselves. It's quite powerful. Yeah. So now that we know a little bit about collections, let's look at lambdas. Yes, this is called, I think it's called a function literal. So this is essentially, we declare a function literal as a lambda expression. So here you can see that the lambda expression takes one argument, there's a type string, then it prints something with the string that we provide here. So you can essentially call this as a function. Like that. No, if you invoke this twice, it will print it twice. Does it really do that in Scala? Ah, okay. Well, now it seems like I'm really that I know this, but I really think so. Yeah. Well, I think it's just two different ways to declare this. This is call a function literal. In this case, I don't think it would matter. No. So there are two different ways to declare. Yeah. You store this lambda inside a variable. Or yeah. Yeah. Okay, so here is just an example of kind of the same thing, but with multiple parameters. Yeah. Hmm? Yeah. Yeah. Yeah, I know what you mean. I do think so. I do think that you can have function inside the other functions. I'm pretty sure. Yeah, I think so. Don't take my word for it, but yeah. 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 Yeah, but isn't So we will actually look at how you can do that in Kotlin as well. I don't think this happens here automatically. I'm not 100% sure, but oh, what do you mean? So if I were to call this twice with two different values, you mean that it should still print Johnny? I don't know, that can't be true. That sounds horrible. No. 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 No, that's horrible. Yeah, but it's a reference to the lambda expression. No. Yeah. Yeah. Oh, but that's memoization, I think, what you're talking about. I mean, that's crazy. Why would... I don't know. Okay. Oh, yeah, yeah. So here you see another example of using lambda expression, and this is like, well, what you will do all of the time when using lambdas and collections. You do this in Java as well, something similar. Here you create an array with names, and you want to sort them by something. They can pass a lambda expression like this, and you declare the variable, and then you call the name of name. So now it will sort the name by length. And yeah, so you can of course use type inference. You can also do that in Java, but it can also be explicit if you like. But Kotlin also have this thing called implicit parameters, and they have, I think, stolen this or borrowed from Groovy, because if you can do it like this. It means it, so you don't have to specify the variable name explicitly. You can just use it, which can be quite handy sometimes. What do I want to show here? Lambdas always returns. Yeah, they do. Yeah, exactly. It's like other expressions, like the if expression and when expression. The last statement will be returned without specifying return. I'm not actually quite sure why they have return at all. I find that a little bit annoying. Yeah, sure, you can break early. True. Yeah. Yeah, true, you can break early, that's... But you... Yeah. But why do I have to use it all over the place when it's not an expression? Yeah, okay. I think this is new in Kotlin 1.1. Yeah, so if you create, this is essentially just create a range of 1 to 5, and sometimes you don't need the actual argument, because here you just generate some random values, 5 random values. You don't care if this is 1 and then 2, it's underscore. This is common in many languages as well, use underscore. Yeah, okay, so you can also declare, this is also lambda expressions, you can declare the parameter types here on the left-hand side as well. You don't have to declare them inside the lambda. They can do like this. So this is a lambda expression that takes 2 parameters and returns an int. Now we come, I don't remember, there was somebody that asked me about this, higher order functions. So yeah, Kotlin definitely supports higher order functions. So here is one example. So here's a function that takes 2 arguments. One argument is just a normal int, but the second argument is a function. A function that takes an int and returns an int. And then the entire function returns an int. So here, yeah, this implementation here, we take value and function, and then we just invoke the function with the value, and we get something back. And this is, yeah, this is good. Yeah, and this is also a little bit interesting. You can actually name types for clarity. You can give the type some name. And yeah, you can use method references. So this is actually the same thing. Here you're just taking a lambda, and the only thing you do with the argument that is passed in is just pass it into this function. It's the only thing that it does. Then you can just use this instead. Colon. That's the same thing. You don't have to. And this is the same thing. You can do this in Java as well. Method references. Oh yeah, and this is a little bit interesting. This is something that you cannot do in Java. So yeah, if you have this range again, and then you do some for each, then you can actually change variables declared outside of the lambda expression. This we cannot do in Java without wrapping it in some neutral wrapper at least. In Java, variables have to be effectively final. I actually think this is bad. Maybe it's good for some form of consistency, but you don't want to do this. What you want to do is probably have some reduce or something here instead. I think this encourages bad coding habits. I'm skeptical. Okay, so this is another little nifty thing that is also available in Groovy. So if you have this function declared like this, and then the last argument, here you can see that this function takes 2 arguments, text and some function. Function that takes a string and returns a string. So if the last argument is a function, you can either, this is how you will typically invoke it without knowing the things that I will show you here. So you will just do text, blah blah blah, and then pass in your lambda expression as a second argument. But you can also write it like this, and this is just reads perhaps a little bit better. So you can actually have the parentheses there, and then you pass the lambda expression. What looks like to be outside of the function, but it's actually, this is equivalent. Which is kind of nice, I think. Sorry? Maybe. I don't see it. But could be. Yeah, okay, now I understand what you mean. Okay, cool. Okay. There's also something called sequences, and if you're familiar with Java 8 and streams, sequences is essentially well, Kotlin equivalents of streams. And it can be an unbound, means it can have infinite size, potentially, which is the same thing as, yeah, streams. And yeah, because what happens here, I mean, you can just, if you create numbers, then you can just call map and filter and then do some stuff with that directly without creating a sequence. In Java, we always have to do a stream or whatever, stream or something. But you don't have to do that here, which is kind of nice. But what actually happens is that if you don't use as sequence, then it will actually create a new list every time you invoke map. So there's some intermediate state that is passed around, which is not always optimal. And when working with infinite streams, you can't work with infinite streams with, yeah, the list is not infinite. The normal list of a sequence can be infinite. So here what actually happens is the same thing as with Java 8 streams. If you have a sequence and you call map and filter, they're lazy, so nothing will actually happen until it reaches this terminal operator, which in this case is reduce. Now everything will happen. And yeah, the reason why it's not called stream is not to confuse with streams from Java 8, because Kotlin supports Java 1.6, which is why I have to create this sequence thing to be compatible with Java 6. And here are just some, well, an example of how you can create Fibonacci with using these sequences. So there is a function that ships with Kotlin called generate sequence. Yeah, so here we actually, what we do here is to generate an infinite Fibonacci sequence. And yeah, we do that by passing in a pair to generate sequence. We pass in a lambda expression that takes the second argument and creates a new pair with the sum of the first and second argument. And then we map it to the first argument. Now we've created an infinite sequence of Fibonacci numbers, and then we just take the first 10 and convert them to a list. And then we get this. This can be really, really useful. Loop. Yeah, this is how you do a for loop in Kotlin. For something something numbers. Yeah, you can probably understand that. Yeah, you can use step. And in here, this is, oh, not in, but when you do dot dot, this is an inclusive range. So 9 is actually included. You can use 2 until 9 if you want to have this what's called inclusive exclusive range. But here it's inclusive. Sorry if there was like this one. Yeah, yeah. No, not in this. You will have to use a different construct. I think. You get like an iterator or something like that. Yeah, look at this. Oh, you want to have the index? Yeah, you can have the index. Okay, you don't. Yeah, but you have that. This is the I don't remember if it's iterable or iterator or something. I mean, you can probably do array of dot iterator or something, and then you have the next and those things. Yeah, yeah, you have to move the pointer. Yeah. Uh-huh. Okay. Hmm. 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 So maybe an equivalence perhaps would be to get like the head of the list and the tail of the list. Maybe that can solve the same problem. Maybe I'm not sure if you can do that in Kotlin. Many other languages that I've seen, at least, I haven't actually seen what you're describing, but I've seen like getting head and the tail and stuff like that. And I think you can solve. Yeah, yeah. No, nothing. No, no. But that's actually, yeah. This is a JVM language. I actually forgot to say that when I started. So now it's a good time to. Yeah. Okay. You're not leaving the room. That's. Oh, look at this. You can get indices like that, right? But yeah, and then you can do array with index, and then you can destructure that like this, making it index and value like that. There's probably more to this if you're not satisfied. Okay, but I'm moving on to something called delegated properties that are kind of nice. Yeah, so, well, simply put, delegated properties are kind of fields that are, or, well, no, properties that are not backed by a field. They're backed by something else. And so essentially it can be used to delegate to some other code. And this is, we were talking about inheritance before, and I think this solves one of the things that you typically use inheritance for in Java many times. It's maybe you have some common piece of functionality in one class and you just want to access this common piece of functionality, so you extend it. But that can lead to problems, because now you have a relationship, is a relationship with this other class, and you don't want that relationship, at least not in my case. So delegated properties is a way to address these things. So here is one built in. Yeah, the keyword that is built in is by. Then this is something that's shipped with the standard Kotlin library. This is lazy. So this is essentially, well, I don't dare to say memoization, but at least something that will cache this value after the first time it's invoked. So now, yeah, the property is string, but what we actually do here is that we query some database. I don't know if you want to do this, but yeah, in this example, yeah, this is what's happening. So when this name here is called for the first time, this query will be invoked, and what's returned by this query will be stored as the name. Next time, it will be cached. Yeah, I think it makes sense. No, that's true. True. Yeah, here's another example with a built-in delegate. Yeah, it's an observable delegate, so if you want to be invoked every time this property changes, this is one way to do it. So you use this delegated property, delegates.observable, to pass in a default value, which is if this property is null, you have this value. And yeah, you get the property, all the new value as parameters. So if we now create a new user, we set the name to first, and then on the second line here, third line, we set the name to second. This will be printed. First it will print no name, because first it's null name. So it will print no name, and then this thing, arrow, and then to first. Yeah, and then it will print first to second. So that can be quite handy. And, yeah. That's a really, yeah, that's a good question. Not sure. Not sure. Yeah, you can create your own delegated properties. Yeah, this is one example. But you can do that, and yeah, and there are some cool use cases for this, I think. For example, if you're used to closure, everything is just a map with some state. You can essentially, if you want to, well, you can have the properties backed by a map. It's yeah, it's shared between multiple objects. I'm not sure if you want to do that, but you can. Okay. So exceptions. There's not too much to say about exceptions. If you know Java, it's essentially the same thing, but there are no checked exceptions in Kotlin, which is a big difference. And another thing is that exceptions are also expressions. So they return something, which is nice. This is, I mean, it's understandable why. I mean, I personally lack some innovation in this space, but it's understandable why they haven't innovated so much, because they wanted to be interoperable with Java, probably. Because there are other ways to handle errors, which I find to be much better in other languages. Yeah, here's an example of a try catch, just to show you that it's an expression again. So here you can see that, yeah, if this works, what's returned by parse int will actually be returned to A. Yeah. No, not in this case. If you throw something, if you throw an exception, then the return type will be nothing. Not here. Now, the return type here, I assume, will be an int with a question mark, nullable int. Yeah, so yeah, if it catches an exception here, it catches it and it returns null. Yes. Yes, thank you. This is also something that Kotlin provides. It's called extension functions. And this is used in a lot of places in Kotlin. The Kotlin standard library ships with a lot of these extension functions. And essentially, it's a way to add functionality to existing classes. Yeah, kind of. Okay, so here is an example. So it's essentially the same thing as declaring a normal function, but instead you have the class that you want to extend before the function name, and they have this little dot here. So here what we're saying is that for each mutable list, I want to essentially add the ability to do swap. I add this swap function. And blah blah, here's the implementation. And this means that when I now use this mutable list, I can call swap on this list. If you have imported this, if you have this extension function in scope, you have to import the extension function. But that can be quite handy. But you should be a little bit cautious because extension functions are resolved statically, which means that an extension function doesn't modify an existing class. It's what happens under the covers is that a static method, I think, but I suppose that a static method is generated somewhere, and the compiler figures out that we can call the static method with a mutable list, for example. And yeah, so if you have cases such as this, like you have a class here that is open, so you can extend from it. Then you have a class D that extends from C. And then you create an extension function, foo, on C, that returns C. You create another extension function with the same name on D that returns D. And then you just have a function here that takes a C as an argument and prints C dot foo. I don't know if you can follow along here, but now if you pass an instance of C into this print foo, what will happen? It will print C. That shouldn't should be quite reasonable, but when you pass in D, it will also print C. And the reason is that we take a C here, and these are resolved statically, so it will see. Actually, when we pass in a D here, it will actually call foo on C, and that can be a little tricky. But then again, you shouldn't use inheritance, so. Yeah, so here is some examples. You can have extension functions declared. Typically, they are declared in a package, but they can also be declared inside a class. And here is some examples of how you import them. You import them the same way as you do with other functions, essentially. And yes, you can also have extension properties. Not only functions, but you can also have properties. And now, this actually surprised me as much as it could surprise you, because it has nothing to do with, well, it actually has a little bit to do with extension functions. Never mind what I said. It actually has, in this case, it has to do with extension functions. But you can actually define a function like infix. So here we actually declare an extension function int called, I suppose this is shift left. So we extend int with shift left. We make it infix. That means that we can call it like this. Infix prefix. So instead of calling shift left and then pass in 1 and 2, we can use it like this. Which is can be it's the same thing as this. Yeah, exactly. Exactly. Very good point. Thank you. So that's pair, or essentially Kotlin adds this extension infix function to int that creates a pair when you do 1, 2, something else. Yeah. No, I think it stores, so in this case it stores it. Let's see, how does that work? Yeah, I don't. No, they don't. Yeah, where is it stored? I think it. Yeah, I think. Now I'm not exactly sure, but I think I read somewhere that Kotlin generates some classes under the hood. Like it generates for each package. Actually, it has to be interoperable with Java bytecode, so it actually generates some class that is a function class, so to speak. And I think it will put the properties in that magic class. Okay, so now we're going to talk about another really interesting thing about Kotlin, and that is when you have a function with a so-called receiver. So this is a typical high-order function that we have seen before. So you have this my high-order function that takes a function that takes an integer and returns a string. And essentially, the implementation here just invokes the function with this argument. So then you can just call my higher order function and with a lambda expression, and then you can make use of this implicit parameter, the it parameter here, that we've seen before. And this is kind of nice. But what you can also do is you can change this definition of the function here a little bit. So here you can see that you have parentheses on both sides of the types. You can imagine that you move the parentheses to the right of the type, and then you add a little dot here. So what this what this allows is that we can access the argument by this instead of it, which is really nice when you create DSLs. And it might not be totally obvious here, but I mean, what's the benefit? But yeah, here is another example. So, because here it's not much of a difference, but the difference is here. Now, inside here we can just do number times 2 is always called times. We don't have to call it dot times. It's called times because the integer is bound to this. And this is used in a lot of places in Kotlin when you create DSLs. Skip this. Yeah. Because now so that's called function with receivers that we saw, and we can use that to create these type-safe builders that are one of the selling points in Kotlin. You can create really nice DSLs that are type-safe. And I'm going to show you one of them. This is a DSL that uses these functions with receivers to create HTML. And as you can see, it looks like kind of a typical templating engine. But this is statically typed. This is just Kotlin, which is kind of cool. It's no magic. It's not a new language. And it just uses these function with receivers. So we'll actually look a little bit how this is implemented. Because it's actually not that hard. I mean, I can understand if you see this for the first time, then it might be a little bit confusing. Now I really hope that I can explain it. Okay, so here you can see here that we start with HTML. So we imagine that we have this class called HTML. It's a standard class, and it has some functions here, a head and a body. This returns the class head. This returns the class body. So now let's look at the function HTML that returns this HTML class. So here you can see we have the function HTML. We have this function with receiver and type HTML. Now it returns unit, so it doesn't return anything of interest. The function itself returns an instance of HTML. So the first thing we do here is that we create an instance of HTML, and then we call this function that we passed in, that is the function with receiver. We simply call it on this instance, and then we return the HTML instance. So what this gives us is the ability now, because now we're inside this HTML block. So now we can invoke these two methods here using this. If that makes sense. Maybe actually, yeah. Oh, actually, yeah. So you can do it like this. You can do this dot head, but it's unnecessary. Let's do it like that. You can imagine that this is really powerful for creating HTML, XML, JSON, or whatever configuration files. And here is the implementation of head and body. I'm kind of abstract it, but I need to look into that. This is one of the selling points of Kotlin. I think this is really quite cool to be able to do this. And you can read more about it here. And there are some other features that you can use. For example, this should not be allowed in HTML. You shouldn't be allowed to put a head inside a head, right? So you can use some DSL markers to avoid these kind of things as well. Okay, so now we're going to look at coroutines. And well, if you're familiar with coroutines, you can probably imagine easily that you can have an entire talk with just coroutines. And if you go into YouTube and search for Kotlin coroutines, there will be a lot of talks on coroutines that you can watch. But essentially, a coroutine is a way to avoid blocking a thread. So it's another kind of construct. In Java, a thread is bound to an OS thread, for for example. But threads in coroutines are much more lightweight. I think it's called lightweight threads, or fibers, sometimes referred to, or green threads. So when you do context switching, for example, it does not invoke the OS kernel at all. Context switching is essentially free. You can have many more of these lightweight threads than normal threads in an application. So that is of course good. And you also avoid blocking. That's a big problem. Yeah, if you want to optimize your code, or if you have a request coming in from the web, you don't want to block the thread when you do a database call, or when you make a request to a third-party server. Then you definitely don't want to block this thread. This thread can be used elsewhere. So that is one use case of coroutines. And it also can simplify the way that you write asynchronous code. Because sometimes it can be quite messy, especially in Java. And what's cool with coroutines in Kotlin is that it's implemented as a library. I think that kind of shows the power of a language as well, if you can do stuff like that. So you can use various different ways. You can use this async await that we have in C# and JavaScript nowadays, and channels that we have in Go and Closure, and you can use generators in yield, Python, I think. And these are just libraries. And there are libraries to interrupt with Rx and JDK8 and JavaFX and stuff like that. And this is experimental in Kotlin 1.1. But yeah, from what I understand, it is quite stable, but it's just that they don't want to like write this API in stone. I mean, they think that everything is good. It is. Well, at least when I have listened to podcasts, they say that it should be good for production, but it might change. If they have something that is wrong when they design the API, they might change this. And also, yeah, here's probably I should mention, because from this one what I've heard, and I heard it from various sources. So when Kotlin in the past introduced breaking changes, they always have this automated way of migrating your existing code into working with the new way that the code should be structured inside in IntelliJ. So it will automatically detect which upgrade changes the code. That should probably work, or that should work well. Yeah, here's a good blog post if you want to know more about this. But yeah, here's a full example, and you can actually, this is really a full example, and it looks, I mean, usually the examples that you see are a little bit prettier than this, but I don't want to cheat. So this is actually a full example. So here we have the main method in Kotlin, and if we ignore this for just 1 second, what happens here is now it creates. Actually, we should start by looking at this function here, because here is, if you look at the function, you see this blah blah function, but here you see something. That's the keyword. That is the thing that allows Kotlin to use coroutines. It's this one keyword. Then async is a library function, but suspend is a keyword. So you can, if you want to call a function from inside a coroutine, it has to be a suspend function. So usually in the examples that you will see, they have kind of a bit of this blocking thing here. And now we used async await library. So, and to the first argument, we pass in what's it called? Coroutine context. And there are different coroutine contexts. Common pool uses the fork join pool of Java. But you can, there are other contexts such as, in Android you can use UI, which means that this coroutine will be dispatched on the UI thread. And there are other coroutine contexts that just says, well, any thread, etc., or use what the parent context is using. There are different kinds of coroutine contexts you can use. And then you call the function here. This async await is promise based, so you will get a promise back. And then here we wait for these two operations to complete, and then we print using coroutine. So we don't actually block the thread. But now, if we actually want to see the result here, imagine that we don't have this. We want to see the result. We don't, because the main method will just exit before the coroutine have completed the calls to these two functions. So in order to actually see the result, we have to wrap it in a run blocking of coroutine. So this will actually block until these two have executed. And usually you don't, I mean, this is not something that you want to use in production. That kind of defies one of the things with using coroutines. But just as a real example, run blocking here, or maybe in tests and stuff like that, it can be useful to have a run blocking. Okay.